Welcome back to part 3 of the definite integration series. Today we are going to learn properties of definite integration. We are going to learn 4 properties. There are totally 7 properties, so we are going to learn the first 4 properties today. So let us go one by one. This is property 1. If you have integration from a to b of f of x dx, it is equal to integration from a to b of f of t dt, meaning if you change the variable from x to t, the value of the definite integration would not change. Now let us see the proof. It is a very short proof. Now let the integration of f of x be g of x plus c. Let's take the LHS. If you have the LHS, which is a to b of f of x dx, you'll integrate that, you'll get a g of x. You'll put the upper limit and then the lower limit with a minus sign in between, so you'll get g of b minus g of a. Similarly, if you take the RHS, which is integration from a to b of f of t dt, that will become g of t, and then you put the upper limit and then the lower limit, you get g of b minus g of a. Basically you get LHS equal to RHS, which means that if you change the variable from x to t or x to theta, keeping the nature of the function same and the limits also same, the value of the definite integration will not change. It will remain the same. Now let's look at the second property. If you have integration of from a to b of f of x dx, that is equal to minus of integration b to a of f of x dx. So if you were to interchange the lower limit and the upper limit, the value of the definite integration will change by a negative sign. So let's see the proof for that. Again, we assume integration of f of x as g of x plus c. We take the LHS, it's a to b of f of x dx, that becomes g of x. We put the upper limit and lower limit, you get g of b minus g of a. Then we take the RHS with a minus sign outside and b to a f of x, so you'll get a minus of g of x from b to a, so you'll put the upper limit g of in place of g of x, so g of a minus g of b in the bracket with a minus sign outside. If the minus sign were to run in, that will make it g of b minus g of a, which would give you LHS equal to RHS, and hence that is proved. Now let's come to the third property. Now in the third property, you have 0 to a of f of x dx is equal to 0 to a of f of a minus x dx. So basically you can put this upper limit in place of x and subtract x. X can get replaced by a minus x and the value of the definite integration will remain the same. So let us take the proof. We'll take the RHS first. So we'll take the RHS and we'll prove the LHS. So we have 0 to a of f of a minus x dx. I'm going to simply substitute a minus x equal to t. So when I derivate, I get 0 minus 1. So minus 1 will be dt by dx, meaning dx will become negative dt. Also the limits are going to change as per what we learned in the previous video. So when x is equal to 0, a minus 0, you will get t is equal to a. And when x is equal to a minus a is 0, so t will be 0. So your limits will get become, instead of 0 to a, will now become a to 0. A minus x has become t, so this will become f of t, and dx has become minus dt. Now what do? We use the second property, and this negative sign is then used to invert the limits. So a to 0 would become 0 to a, and the negative sign would disappear using property 2. And also using property 1, I will change the variable which was t to variable x. So 0 to a, this f of t will become f of x dx, and that is precisely what your LHS is, and therefore we have proved the third property. Now let's come to the fourth property. We have integration from a to b of f of x dx equal to a to b f of a plus b minus x dx. So you basically replace x by the sum of the two limits minus x, and still the value of the definite integration will not change. Fine. So we will start the proof by taking the RHS. Now when we take the RHS, a to b f of a plus b minus x dx, we will simply substitute this a plus b minus x equal to t. So 0 plus 0 minus 1, we derivate, so 0, a and b are constant, so the derivative of those are 0. Minus 1 is the derivative of minus x, and t will become dt by dx. So therefore dx will become negative dt. Also the limits are going to change. What was a to b, now when you put x is equal to a a minus a will get cancelled, you will get t is equal to b. And when you put x is equal to b, so b minus b would get cancelled, you will get a. So what was a to b now will become b to a. So here we go. Your RHS now will become b to a instead of a to b. A plus b minus x has become t, so that is f of t, and dx has become minus dt. Again, we will use the second property and invert the limits and make the negative sign disappear using property 2. So a to b, b to a has become a to b, negative sign is gone away. And also, we will replace the t by x using property 1. We'll replace the variable t by variable x, and that is what you get, a to b of f of x dx, which is your LHS. So these are the 4 properties. Now we are going to do some examples based on properties 1 to 4. So let's take the first question. You have 0 to pi by 2 sin x upon sin x plus cos x. Now here's, I'll call this 1. I'll call this first step itself 1. We'll see why I'm calling that 1 in a bit. Now I'm going to replace x by pi by 2 minus x, which means I'm using property 3. So everywhere I see x, I'll replace it by pi by 2 minus x, because your a is pi by 2 over here. It's 0 to a, so 0 to pi by 2 is a. So sine of pi by 2 minus x upon sine of pi by 2 minus x plus cos of pi by 2 minus x and dx. Now what is sine of pi by 2 minus x? It is cos x. What is again sine of pi by 2 minus x here? Cos x. And what is cos of pi by 2 minus x? It is sin x. And so I'll call this 2. Now what I'm going to do with this 1 and this 2? I'm going to add 1 and 2. So when I add 1 and 2, left hand side I plus I will become 2i, and on the right hand side you'll get 0 to pi by 2, this plus this, so sin x upon sin x plus cos x, plus cos x upon cos x plus sin x. So the denominator is same, isn't it? So sin x plus cos x will be the LCM, and you'll simply add the numerators, which is again sin x plus cos x. So what happens? You get sin x plus cos x upon sin x plus cos x, which get cancelled. You get 1. So 0 to pi by 2, integration of 1 is x. You put pi by 2 in place of x minus 0, so you'll get pi by 2 minus 0. Remember, there is a 2i on the left hand side, so we'll bring this 2 down, so I will become pi by 4. I hope that is clear. Now let us understand this with another sum. Now we have question number 2 here, where you have integration from 0 to 3 dx upon x plus root of 9 minus x square. Now when you have a root of a square minus x square in your question, the obvious thing to do is put x is equal to a sin theta. So we are going to first of all put x is equal to 3 sin theta, because a square is 9 here, so a is 3. So x becomes, or x is put as 3 sin theta. So dx becomes 3 cos theta d theta, right? And we also are going to change the limits. So what were 0 to 3 now are going to change for theta. So when x is equal to 0, 0 upon 3 is 0, so sin theta will be 0. So obviously theta of 0 is 0, so therefore theta will be 0. When x is equal to 3, 3 upon 3 becomes 1, so sin theta is 1, which means theta will be pi by 2, because sine of pi by 2 is 1. So 0 to 3, the limits have now become 0 to pi by 2. So you have 0 to pi by 2, the limits here. Dx becomes 3 cos theta d theta, x is 3 sin theta, plus this is root of 9 minus 3 sin theta whole square, so that is 9 sin square theta. So you take 9 common here, 1 minus sin square will become cos square, so 9 cos square will come out of the root as 3 cos theta. So you have 3 cos theta up, you have 3 sin theta plus 3 cos theta in the denominator. We'll take 3 common and cancel it upar niche, right? In the numerator and denominator, 3 gets is taken common in the denominator, then cancels with the 3 in the numerator. So now you're left with a cos theta upon sin theta plus cos theta, limits 0 to pi by 2. I call this 1, and now I will do exactly what I did in the previous sum. So I'm going to replace theta by pi by 2 minus theta using property 3. So everywhere I have in place of theta pi by 2 minus theta in all 3 places. So cos of pi by 2 minus theta is sin theta, sin of pi by 2 minus theta is cos theta, again cos of pi by 2 minus theta is sin theta. I call this 2, and then I again add 1 and 2. So I plus I will become 2i. This will become 0 to pi by 2. You have the LCM cos theta plus sin theta plus cos theta is the same, and so we'll just simply add the numerator. So cos theta plus sin theta will become cos theta plus sin theta upon, and then you have the denominator cos theta plus sin theta, cancels, you get 1. integration of 1 is theta, you put pi by 2 minus 0, and again you get the 2 down, you get pi by 4 as the value of your definite integration. Now let's come to the third question. You have integration of from 0 to pi of cos x upon 1 minus sine raised to mx. It's a power m. Okay, now I call this 1, and I again simply replace x by pi minus x using property 3. So cos of pi minus x upon 1 minus sine raised to m of pi minus x. Okay, so what is cos of pi minus theta? It is minus cos theta, right? It is, the angle is going into the second quadrant, cos is negative in the second quadrant, so you'll get a minus cos x. But sine of pi minus x is positive sine x, so this remains as it is, so it becomes 1 minus sine raised to mx. I call this 2. Then I simply add this 1 and 2. So when I add 1 and 2, I plus I will become 2i, right? And 0 to pi, you'll get, you have this cos x upon 1 minus sine raised to mx. You have minus cos x upon 1 minus sine raised to mx. So the LCM is common, so the denominator, both the terms are same in the denominator, so 1 minus sine raised to mx will remain as the LCM, and cos x minus cos x is what you get. So cos x minus cos x, obviously cos x minus cos x will get cancelled, you'll get a 0, and so 2i will become 0 and I will become therefore a 0. Now let's come to the fourth question. You have 0 to pi by 4 of log of 1 plus tan x. I'll call this 1. Now I'm going to replace x by pi by 4 minus x because it's 0 to a, so pi by 4 minus x, so that's using property 3. So 0 to pi by 4 you get log of 1 plus, and what is tan of pi by 4 minus x? It is 1 minus tan x upon 1 plus tan x. Tan of pi by 4 minus theta is 1 minus tan theta upon 1 plus tan theta. So I've used the Trigo formula. 1 minus tan x upon 1 plus tan x. Now I take the LCM here. So I cross multiply. So 1 plus tan x plus, this is 1 minus tan x, the whole divided by 1 plus tan x. So tan x minus tan x gets cancelled. You get 1 plus 1, which is 2. So you end up with a 0 to pi by 4 log of 2 upon 1 plus tan x. I call this 2. So now I'm going to add 1 and 2 again. So when I add 1 and 2, I get I plus I 2i, right? 0 to pi by 4, you get log of 1 plus tan x plus log of 2 upon 1 plus tan x. So when you do log of a plus log of b, it is log of a into b. So you'll get log of 1 plus tan x into 2 upon 1 plus tan x. So 1 plus tan x gets cancelled. You're simply left with the log 2, which is a constant which goes out of the integration. So you're left with the integration of 1, whose integration is x. Upper limit and lower limit is put there. So you get pi by 4 minus 0. And there is a 2i, remember, on the left hand side. So 2 comes down. So you get pi by 8 into log 2 as your answer. Now let's do the last question for the day. Now we have integration from 1 to 3 of root of x plus 5 upon root of x plus 5 plus root of 9 minus x. I'm calling this 1. Now I'm going to use property 4 and I'm going to replace each x by 1 plus 3 minus x. Isn't it? A plus b minus x. So x has got replaced by 1 plus 3 minus x. 1 plus 3 minus x, and this plus 5 as it is. Similarly here, 1 plus 3 minus x plus 5 plus root of, you have this 9 minus, and then this x gets replaced by 1 plus 3 minus x. Now what happens with that? This becomes 4 plus 5, 9 minus x. Even here it becomes 9 minus x, and here it becomes minus minus plus x, and 9 minus 4 is 5. So you get a root of x plus 5. So what was x plus 5 has become 9 minus x, and what it was 9 minus x has become x plus 5. And I call this number 2. And so now when I add 1 and 2, I plus I will become 2i. The right hand side, integration from 1 to 3, if you see the denominators are same, so that's the LCM, and you simply add the numerators. So root of x plus 5 plus root of 9 minus x, the whole divided by root of x plus 5 plus root of 9 minus x, they simply get cancelled. You get 1, integration of 1 is x, you put the upper limit and lower limit, you get 3 minus 1, which is 2, but 2i is 2, which means I will become 1. I hope all these sums were clear and also the properties. Until next time, goodbye.